The third TAP for Chapter 12 also created some problems for students. And let's talk that one through. Parts A and B weren't particularly troublesome for students, but let's start there anyway. A, how many hours of labor are hired in a competitive labor market outcome? What is the wage rate? We see labor demand equals labor supply at a quantity of 20 million person hours. I didn't quite get this graph to be big enough. So 20 million hours at 10 per hour. Now, some students ask me, isn't it just 20? Well, yeah, it's 20, but notice the units are million hours. 20 million is a lot different than 20. So if you get a graph like this, make sure you get the units right in your answer. Very important. Now, my brother this weekend told me the acronym CYA, cover your ass. This is me CYA-ing, if that's a word. This is not a particularly good framework with which to analyze the minimum wage, the impact of a minimum wage law, because there's so many other things going on in the economy. I already talked about that in class. But because this is an important problem, and this is a very typical framework to at least get a first cut at this question, I had you do this problem. I wanted to make sure you could do it. It's in the homework that's due on Monday night next week. So anyway, making all the reasonable assumptions that I would need to make to use this supply and demand framework to analyze the effects of this law, that's me covering my bottom. All right, well, we have a minimum wage law prevailing. It's supposed to be a $15 an hour minimum wage law. I see this typo now, $15 per hour. Oh, I see. It's not a typo. It's just up here. $15 per hour minimum wage. All right. So 15 again. This is sort of a small graph to be doing this on, but the way this works out is that we have 15 million hours at. That's supposed to be an at 15 per hour. And some of you were drawing the supply curve and figuring out labor supply. Doesn't matter. It takes two to tango, takes two willing parties to a transaction. So it's always the smaller number of demand and supply in the presence of a price ceiling or a price floor. In this case, it's a price floor. It's always the smaller number that is relevant. So it's no employer would hire more than 15 million hours per week. I've got the numerical calculations in my answer key, but I wanted to make sure you understood where those numerical answers came from. So I'm going to just do this using our letters for welfare analysis. We did that early in the semester, chapter 7, I believe. So then the numerical answers are in the answer key. So let's proceed through this problem. Under the competitive market outcome, employer surplus, remember employers are the demanders of labor. So the area under the demand curve, above the price line, the price was 10, we got areas A, B, C. And then worker surplus, just D and E. It's the area below the price line, above the the marginal cost of supplying one more hour to market, D, E. And we get A, B, C, D, E as total surplus. Now I'm going to change color. Under the minimum wage law, note that now the wage has gone up to 15 an hour. The employer's surplus is just area A. And now we have this interesting effect for employees. Their surplus has become areas B, D. and we get total surplus A, B, D. Notice that employers are unambiguously worse off. They lose areas B, C in surplus. That's gone to them. Workers, some gain and some lose. Notice that the net effect on workers, area BD minus DE, they've gained area B, but they've lost area E that they used to have. And so this area B represents the higher wages of the people that were able to keep their jobs at that higher minimum wage. Area E is the lost surplus because now there's 5 million labor hours that aren't hired anymore. So that's why there's a bit of an ambiguous effect on workers. We notice that area B is much bigger than area E, so workers on net are better off. And you see that when in the answer key when you calculate numerical answers. And finally, there's a deadweight loss. Areas C, E are just lost completely to the economy. So who wins, who loses? Most people say, oh, workers win, but that's not quite right. Workers who keep jobs or who get the minimum wage jobs win. Workers who now can't find work lose. And then employers unambiguously lose. So this middle effect is the one that students often miss. So make sure you're not one of those students that miss that one. That's the A paper picks up that subtle point as well. And then now this E was the one that gave people fits. And I understand that. So let's work through that problem. I've got the numerical calculations in the answer key, but I want to show you here how I got those numbers. So how much would it cost the government for each hour worked to provide an earned income tax credit under which workers as a group receive the same economic surplus as they do under the 12-hour minimum wage? So the way I did this is to ask how would I would increase worker surplus through an earned income tax credit by the amount by which they were net better off. Let me change colors. Pick. We'll go back to black. We haven't used black in this screen. So I took this net gain, this B minus E was the increase in worker surplus, and that turned out to be $71.25 million in total. And then I divided that by the number of worker hours. That was 20 million. Because we want $1 per hour answer. So and by assumption, we have the same level of employment as the competitive outcome. Of course, that's not true, right? There'd be some increase in employment under a subsidy. Actually, well, I can show you that. If there were a subsidy, let's say equal to this vertical distance, the quantity of labor would go up about, so we're just ignoring that and saying, the quantity of workers hired is just stuck at 20 million. So we take that 71.25 million divided by 20 million, and we get the answer that the subsidy necessary to bring workers collectively up to that increase in well-being, up to that increased well-being that they achieved under the minimum wage law, that wage subsidy is going to have to be $3.56. I didn't write my 3, and it's actually 0.2, and and a quarter of a cent as well. So again, let's write that out a little bit more neatly. When you do that calculation, $3.56, and if you want to take it out to 4 digits, 56 and a quarter cents, 56.25 cents. All right, that's how we did it. Hope that made sense. You could change the numbers and make another practice problem for yourself if you like. And when you're at that level, you know you're ready for the quiz. And you know that you know this stuff real well, which is, of course, the important point.